Imagine a simple notebook. In that notebook, you write down who sent money to whom. John sent $50 to Emma. Emma sent $20 to David. That notebook is a ledger. Now imagine something different. Instead of one notebook sitting in one office, there are thousands of identical copies all over the world. Every participant has the same ledger. Whenever a new transaction happens, everyone checks it. If most participants agree that it's valid, the transaction gets added. Once written and confirmed, it cannot realistically be erased or changed. That is blockchain. The word blockchain literally means chain of blocks. Each block contains a list of transactions, a timestamp, a digital fingerprint of the previous block. That digital fingerprint is called a hash. Think of a hash like a unique signature created from the block's content. If you change even a single character in the block, the hash changes completely. That means if someone tries to alter an old transaction, the entire chain breaks. Every following block would no longer match. If you like similar educational content, please like, subscribe, and share the video with your friends. It would be immediately obvious. This is why blockchain is considered secure. But here's the big question. If there is no bank, no company, no central authority controlling the ledger, who decides what is true? How are transactions verified? And how do we prevent cheating? In the traditional financial system, there is always a central authority. When you send money, your bank checks your balance, verifies your identity, approves the transaction, and updates its private database. The bank is the trusted middleman. Blockchain removes that middleman. When you send a transaction on a blockchain network, that transaction is broadcast to thousands of computers around the world. These computers are called nodes. Each node holds a full copy of the ledger. Instead of trusting one bank, the system relies on distributed verification. Here is what happens step by step, but in simple terms. First, the network checks whether you actually own what you're trying to send. On a blockchain, ownership is proven through cryptography, not through identity documents. Every user has two keys, a public key, like an address, a private key, like a secret password but far more secure. When you send a transaction, you sign it with your private key. This creates a digital signature, a mathematical proof that you are the legitimate owner of the funds. Other nodes can verify the signature using your public key. They don't need to know who you are. They only need to confirm that the math works. Second, the network checks that you are not trying to spend the same funds twice. This is called the double spending problem. Blockchain solves it by keeping a synchronized global ledger that everyone agrees on. Once transactions are verified, they are grouped together into a block. But who decides which block becomes the next official block in the chain? This is where consensus mechanisms come in. A blockchain must ensure that the majority of the network agrees on a single version of history. If different nodes had different versions, the system would collapse. Consensus is the process that keeps everyone synchronized. Now we reach the core mechanism that makes blockchain secure. If thousands of computers hold copies of the ledger, how do they all agree on the same version of history? This agreement process is called consensus. Without consensus, the system would split into conflicting versions. With consensus, everyone follows the same chain. Let's start with one of the most well-known systems, proof of work. In proof of work, computers called miners compete to solve a complex mathematical puzzle. It's important to understand something. The puzzle has no practical meaning. It doesn't calculate weather, cure diseases, or design bridges. Its only purpose is to make block creation difficult and expensive. Miners repeatedly guess numbers until one of them finds a number that satisfies strict cryptographic conditions. This process requires enormous computational effort. When a miner finds the correct solution, they broadcast it to the network. Other nodes verify that the solution is correct. If it is valid, the new block is added to the blockchain. The winning miner receives a reward. Why did this secure the system? Because altering the blockchain would require redoing all the work for that block and every block after it, and doing so faster than the rest of the network combined. In large networks, That would require controlling more than half of the total computational power. This is often called a 51% attack. In reality, achieving that level of dominance is extremely expensive and practically infeasible in large networks. However, proof of work has a downside: energy consumption. Since thousands of machines compete continuously, large blockchain networks consume significant electricity. This led to alternative systems. One of the most important is proof of stake. Instead of competing with computing power, participants lock up a portion of their cryptocurrency as a stake. The system then selects validators based on the amount staked and other rules. Validators propose and confirm blocks. If they act honestly, they earn rewards. If they attempt to cheat, they can lose their stake. In this model, security is based on economic incentives rather than computational power. Proof of stake dramatically reduces energy usage while maintaining network security. Both systems aim to achieve the same goal: prevent fraud, maintain a single shared history, eliminate the need for a central authority. By combining cryptography, distributed networks, and economic incentives, blockchain creates a system where trust emerges from math and consensus rather than institutions. When people hear the word blockchain, they usually think of one thing: Bitcoin. But Bitcoin is only one application built on blockchain technology. Blockchain is the infrastructure. Cryptocurrencies are tools that run on that infrastructure. And not all cryptocurrencies serve the same purpose. Let's break it down clearly. Bitcoin, digital money without a bank. Bitcoin was created to function as decentralized digital money. Its core purpose is simple: allow value to be transferred directly between people without a bank or central authority. Bitcoin has a fixed maximum supply of 21 million coins. That scarcity is built into the protocol itself. No government can print more. No company can change the rules without network consensus. Because of this, many people describe Bitcoin as digital gold. It is designed to be scarce, resistant to censorship, independent of central control. Its main function is value storage and transfer. Ethereum, a platform for smart contracts. Ethereum expanded the concept. Instead of being only digital money, Ethereum allows developers to run programs directly on the blockchain. These programs are called smart contracts. A smart contract is simply code that automatically executes when certain conditions are met. For example, if payment is received, ownership of a digital asset transfers automatically. No bank, no lawyer, no intermediary. Ethereum turned blockchain into a programmable system. On top of it, developers built decentralized applications, financial services, digital tokens, and entire ecosystems. Stablecoins, stability in a volatile market. Cryptocurrencies are often volatile. Their prices can rise or fall quickly. Stablecoins were created to solve this. Stablecoins are designed to maintain a stable value, often pegged to the US dollar or euro. They function as a bridge between traditional finance and blockchain systems. Instead of holding a volatile asset, users can hold a digital token that tracks a stable currency. Specialized blockchains. Beyond Bitcoin and Ethereum, there are thousands of other projects. Some focus on faster transaction speeds, lower transaction fees, improved privacy, interoperability between blockchains, energy efficiency. Each project modifies the core blockchain idea to optimize for specific goals. The key point is this: blockchain is not just about digital money. It is a system for recording data in a decentralized, secure, and nearly immutable way. It can be used for financial transactions, supply chain tracking, identity verification, digital ownership, decentralized finance, voting systems. We began with the idea of a simple notebook shared across the world. We end with a global distributed system capable of moving billions of dollars, running autonomous programs, and redefining how trust works in the digital age. Blockchain replaces institutional trust with mathematical certainty. It is not magic. It is cryptography, distributed systems, and economic incentives working together.